Okay, so today we're going to talk about tangent and cotangent and how to graph them. We've already talked about cosine, sine, and cosecant. Remember, cosine, sine, cosecant, and secant all had a period of 2 pi. Cotangent and tangent are going to have a slightly different period. So let's investigate and see what we get for our period. So tangent at 0 is going to be 0. Tangent at pi over 4 is 1. Tangent at pi over 2 is undefined. Tangent at 3 pi over 4 is negative 1. Tangent at pi is 0. Tangent at 5 pi over 4 is going to be 1. Tangent at 3 pi over 2 is undefined. Tangent at 7 pi over 4 is negative 1, and then 2 pi is back at 0. Notice that it follows a pattern, and the pattern starts here at 0, and it finally gets back to 0 at pi. And then it repeats itself, right? So 5 pi over 4 is the same thing as pi over 4. 3 pi over 2 is the same thing as pi over 2. So our period here is now till pi. So our period is no longer 2 pi over b, but pi over b. Again, where cosine, sine, secant, and cosecant are 2 pi over b. So let's check out this graph. We're still going to go from 1 to negative 1, but our period now is only 2 pi. So half of pi is pi over 2. Half of pi over 2 is pi over 4. So pi over 4 is our interval. So 1 pi over 4, 2 pi over 4 is pi over 2. Then we've got 3 pi over 4 in between pi and pi over 2. So at 0, we said the value was 0 again. And then at pi over 4, it was 1. And then we have an undefined. And remember, undefined means we're going to have an asymptote. So we have an asymptote there at pi over 2. And then at 3 pi over 4, we're at negative 1. And at pi, we're back at 0. So these graphs go on forever towards their asymptotes, okay? Never actually reaching them. So let's talk about the domain, range, and period. We already said the period was pi. The domain for one period is all we're looking at. So the domain for one period here is that we included 0 and we made our way to pi over 2. We did not include pi over 2 because it's an asymptote, and then we pick back up at pi over 2 till we get to pi. And that's only for this one period. The range here is from negative infinity to positive infinity because our y values can be whatever number that the graph is hitting at that time. Let's look at cotangent, right? The reciprocal of tangent. Its period, again, is going to be pi over b. So the reciprocal of tangent at each spot is what we're going to be looking at. So the reciprocal of 0, because remember tangent was 0, is undefined. And then tangent at pi over 4 is 1. If you flip that, you still get 1. At pi over 2, it was undefined, so cotangent is going to be 0. At 3 pi over 4, it's going to be negative 1, because if you flip negative 1, you still get negative 1. Remember, flipping, taking the reciprocal, and taking the opposite are different things. Taking the opposite is multiplying by a negative. Taking the reciprocal is just flipping the top and the bottom. So at pi, we were back at 0, so we're going to be undefined there. Then at 5 pi over 4, we're going to start our pattern again because cotangent only has a period of pi. So we're going to have 1, and then 0, and then 1, and then undefined again. So cotangent starts with an asymptote, where tangent started with a point. It's still going to go from 1 to negative 1, and our period out here is to pi. Again, we're at pi over 2, and then pi over 4, and then count your interval, so 1, 2, 3, pi over 4. And again, we start with an asymptote on this one, and we end with an asymptote, and the graph falls in between. Now remember, the pattern is always going to be the same for all of these graphs that we've talked about so far, and you are always, 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 always going to have 5 points. I must see 5 points on your graph. So the asymptotes count as points, okay? So I already have 2 on there, and I just need to put my other 3. And so at pi over 4, cotangent is at 1. At pi over 2, we're at 0. And at negative 1, at 3 pi over 4, we're at negative 1. So this graph, again, is going to go on forever towards its asymptotes. And if we had looked at tangent on a different period, it would look like this too. Okay, so there is cotangent. Okay, let's talk about its period, right? Its period, we're going from 0 to pi, but not including them. The range is the same as tangent. It's negative, that looks like a positive. It's negative infinity to positive infinity. And our period, again, is pi. So let's talk about what that looks like with amplitude changes as well as altitude changes, or amplitude changes and period changes. Okay. Again, we'll get to phase shifts in the next video. So our A value here is 3. Our B value is 2, right? We're getting them from our equation there. Our period is pi divided by our B. So pi divided by 2. So we're going to have pi over 2 out here. If we cut pi over 2 in half, we get pi over 4. And remember, cutting something in half is like multiplying by 2, or multiplying by 1/2. So if I'm down here and I'm multiplying pi over 2 by 1/2, I multiply across, I get pi over 4. Okay, divide pi over 2, or pi over 4, and we'll get pi over 8. So we've got pi over 8. 2 pi over 8 is equal to pi over 4, and then we've got 3 pi over 8. And our amplitude there is 3, so we're going to go up and down 3 and negative 3. This is cotangent. So we start with an asymptote. Okay, so we start with an asymptote. It's not flipped. There's no negatives. So the normal graph starts at the top at 1. So we're going to start at 3 because that's our new amplitude. We're going to go to 0. And then we're going to go down to negative 3. And then we'll have an asymptote. And then we just draw our graph in. Okay, so there is cotangent. Got 2 more examples here for you. So our A value here is 1/2. Our B is 4. So our period is 2 pi. Oh, no, pi. Sorry, not 2 pi. Is pi over 4. So pi over 4 is here. Multiply by 1/2, we get pi over 8. And then we're going to cut pi over 8 in half, and we get pi over 16. So 1 pi over 16, 2 pi over 16, 3 pi over 16. And our amplitude is only 1/2. All right, this is tangent. So we're starting at 0. So tangent starts at 0 and then goes up to our amplitude. Then we have an asymptote, and then we're down at negative 1/2 and up to 0. Now this would have been flipped if this was negative, but again, there's no negative here. And then we just draw in our graphs. Notice that it is the same pattern as the original parent function, just has different intervals. All right, one last one. We've got negative cotangent. So our A value is not negative 1 because it's absolute value. So it's positive 1. But the negative tells us to flip. Okay. And then our B value is pi. So our period is pi divided by pi, or 1. So that means we've got 1 out here, 1/2 in the middle. 1/2 of 1/2 is 1/4. So 1/4, 2/4, and 3/4. Okay, our amplitude was 1 and -1. We are at cotangent, which means we're starting with an asymptote. Okay, so we're going to start at the asymptote and we're going to end with an asymptote. Now, the negative tells us to flip. So normally cotangent starts up at 1, but because we're flipping, we're now going to be at -1. 0 doesn't flip, so it still stays at 0, and then the -1 goes to our +1. And then we draw in our graph. Okay. If you have any questions, feel free to email me, talk to somebody else in your class. The next video will be about phase shift and moving the graph left or right.